let's do a little driving video. Since I'm going to be stuck in traffic anyway, I got to head over to Oscar's, try out his new components. So, and then I'll bring those home and burn them in, and we'll do TSPs on them. I think they're great for, I think they're fresh for, or ripe, I should say, ripe for debadging. So, and then reselling. So again, yeah, that's really the way to go, because that way when you're launching your own shit, people go, I've never heard of this, and you go, that's fine, listen to the performance. It doesn't matter if it's a subwoofer, highs, whatever, amp, they all sound the same. So if you find somebody that can hear the difference, get the fuck away from them, because they're a fucking liar. Those people exist in like wine tasting. So, it's got a sake feel. Tastes like a Sunday sock after Sunday school in 8th grade. So dumb. Anyways, I wanted to talk about a little bit. There's a couple of questions that came up from my talk about amplifiers a little bit. A couple of scenarios I want to run by you. So if you look at an amplifier, let's say signals on this end, outputs on this end. There's actually 3 sections to an amplifier. One is the preamp section, and that's basically to control the signal, to use filters, and basically to drive it into the amplifier section. So in this case, I'm just doing preamp, amplifier, and then power supply, which is supplying the juice for the amplifier section. So there's 3 sections. Ready? Preamp, amplifier, which is the output, and then there's the power supply. Okay, so power supply turns 12 volts into whatever rail voltage the amplifier needs, as per the designer. And there are lots and lots of designs. There are lots of ways you can do it. What ends up happening is that whatever it is, it gets stepped up. They pulse the DC in, and it gets stepped up through those transformers to whatever voltage they need, typically a little bit over voltage. Like if they need 35 or 30 volt rails is pretty typical. And they'll step it up to like 33, 34. And then some of them will call it close, and they'll use capacitors that are like 35 volt. That's kind of too close. In that case, you actually want to be a little more conservative and use like a 50 volt cap, because it's like half a penny more. But anyways, so there's 3 parts on the amplifier that can, or 3 or more that can be saturated. Okay, and when it's saturated, that means it's basically on all the time, and it's going to cause some distortion and some clipping and things like that. So a lot of people were talking about, well, you know, by basically confronting me about what I said on, you know, when people say, oh, I don't have the electrical to run, you know, blah blah blah, whatever the impedance is, and that is not true. You just have to turn it down. That's all. You just can't turn it up to whatever you had it before, 35 or whatever. And you should always adjust the gain depending on your load, depending on what impedance you're running. Some people just kind of ignore that, and it does get kind of, it's like there's not much of a difference between 1 ohm and 2 ohm, so they just kind of leave it, and guess what? It works fine. So there's a lot of wiggle room in there. As far as you can do, but yeah, if you don't have enough current, and sometimes because you're pushing on the current, the voltage will drop. If either one of those drops, there's a little computer inside most amplifiers, not all of them, most amplifiers, modern amplifiers now, and they will do a couple things. Sometimes they do nothing, and that's where you get some clipping. It'll indicate that in the rails, and the rails will sag, as they call them. And you'll get clipping that way. So whenever you're running an amplifier, though, full bore, there's always a weak link. So and it can be the preamp, it can be the amplifier section, and it can be the power supply. And so it's funny how sometimes, like, depending on who is in charge of the marketing for the amplifier, they can sit there and talk about this. And I know all this because I've suspected it for years. And then I talked to at least 2 engineers from PPI that confirmed it, which was that basically you can overbuild the power supply. You can say, oh, this is a really stout power supply, It has, you know, this many, whatever it is, 10 TO220s that do this, and you look at the specs, and then you do the math and you add it all together, and you're like, oh, okay, this one's capable of, you know, this much current. So, but it depends on how much the amplifier is using, the amplifier section. So you can overbuild the power supply, but again, you're always going to find the weak link. Let me see if I can let this person through, because nobody stops for people. But that's just one link in the chain. Okay, so the other way is like, let's say you rate your power supply at 1100 watts RMS, and then your output section, right, which is your actual amplifier section, let's say it's rated at 1200. You can push one side a little bit to get a little more, but again, you're only as strong as your weakest link. So if you have an output section that's really fucking stout, like let's say you use TO with the 247 devices, you know, because you're like, oh, this is a really big device, it's fucking awesome. Well, if your power supply can't keep up, then again, that's your limitation, and you'll get clipping in there as well. So and then there's the third one, which is if you're dealing with, or actually the fourth one, if you're dealing with Class D, sometimes designers or engineers or the factory or whoever it is will cheap out on the output section. And what I mean is the output choke, the filter section. There's an actual analog filter on a Class D to take away the switching noise, and that's usually through at least an inductor and then at least a cap. Typically it's just a 12 dB, but some of them are 18 dB or even 24 dB slopes. And so if it's a 18 dB slope, that means there's an inductor, a capacitor, and then there's another inductor. And then some of them will have an inductor, a capacitor, another inductor, and then another bank of capacitors. And all of those have to be within parameter to handle that kind of current. And let's just say it's 1100 watts, right? That's a lot of what they call magnetics. That's a lot of copper. That's a lot of ferrite cores. That's a lot of just stuff. And a lot of companies, especially in these cheaper amps, they'll cheap out and they won't use this hardcore stuff. And then sometimes they blame it on you. They're like, oh, you pushed it too hard, it burned it up. And they're not wrong, because if you did use it within parameter, it would not have done that, right? But then sometimes amplifier companies will, you know, like I've talked about before, like with Boss, they'll rate a 350 watt amp, they'll rate it for 3,800 watts. So I don't know. It's again, there's a lot more to it than just what Big D Wiz knows or even tells you. And the other thing is that that was the other one I wanted to talk about, was like so let's take the example of a 1 ohm stable amplifier, okay, and let's back it off like halfway. It's a 1,000 watt amp, okay. At 2 ohms it does 500 watts, okay, and at 1 ohm it does 1,000 watts. The other way that it can do, it actually does virtually the same power at both impedances. So let's say let's say the input is 1 volt and the output is at 1 ohm is 1,000 watts, right? And that's basically, you're maxing out the whole thing. You're maxing out the power supply, you're maxing out the amplifier section. You're not maxing out the preamp section because it's only 1 volt. And actually 1 volt is quite a bit. So like that little OSC2 that I have, the max RMS on that is 0.75. 0.75 RMS, and you can run virtually any amplifier into clipping. Again, it depends on where your gain is set, where your input is set. So back to my example, 1 volt in, okay, 1,000 watts out at 1 ohm. So there's a couple ways that you can change this, and the amplifier does not change. Again, the amplifier just takes a small signal, turns it into a big signal, right? Turns 1 volt in into 1,000 watts. So what happens if you put in half the input? So if you put in half a volt, what's your output? Half the output. It's 500 watts. See how that works? So you go, wow, let's do 2 ohm. Okay, so 2 ohm input with 1 volt input gets you what? 500 watts. So all I gotta do is put the input to 2 volts. See how that works? So now you're doubling your output. 2 volts in, 1,000 watts out at 2 ohm. The amplifier is more than capable to do the 1,000 watts, but that's all it is. Again, it's like a seesaw. There's always a balance, right? So like when guys, they like to hot dog their amps and they, oh, did I pass? Oh, I passed Oscars. I don't think he texted me anyway. Like, you know, like they get an 8-volt preamp. They're like, oh, I gotta have a line driver. I gotta have all this kind of stuff, and that's all dumb bullshit. All you have, then what happens is you turn your gain all the way down. There you go. And in fact, if they're actually you know what they do. If you look all the way on the left, typically it's like 8-volt input, and then all the way on the right is like 0.2 or something like that, because that's what it's doing, is it's padding it down because your dumbass is line driving the shit out of it, and it tries to equalize it. It tries to find a clean signal. You're like, oh. So if you keep the gain all the way up, and then you have that 8-volt signal coming in, yeah, it's gonna fucking saturate it and clip the shit out of it. And that's what Steve Mead was doing when I first contested what he was doing on those stupid LOCs. So again, he's like, well, it's clean output. Yeah, but if the input is not set up for that voltage, it's gonna saturate it. It's gonna fucking clip it. So to make his test work, all he did was use cheap ones that don't have that much input. What you find out though, like I did, is like on the OSC2, right? The OSC2 is a little handheld sound generator with a digital readout. It probably wasn't even made by Rockford. Rockford just put their name on it, and it's basically before all that Tony DeMore shit, where you just, like, it was called the Perfect Interface. I think was I think they tried it twice. Yeah, I think it was Perfect Interface, and then the Connecting Punch was the other time they tried to do accessories and shit like that. Anyways, it was under the Perfect Interface, and that's when I read the specs on it. I was like, what? It's only powered by a little 9-volt battery. Now mine, on my bench, I have a little wall wart, a little power supply that supplies, like, I think 10.1 volts, and then I just put a little adapter on it so that it's hooked up all the time, because that's the thing that I always would do to that thing, is I would always forget about it and I leave it on, and then it fucking drains the battery. And so if I just put a power supply on it, then when the electricity's on, there you go. My signal generator is on all the time. So that's what you see on the other test bench. Excuse me, that old analog one. Not that the OSC2 is a digital one, by the way. It's analog as well. It just has a frequency counter that's been calibrated to match the output versus the analog reading. You got to just sync those up at the beginning, just like when you do an SPL meter. I went over that with you guys, where it's a little piezoelectric disc, and then you test it at a known SPL, and then you just notate the voltage, and then you just do a little math, and then you go, oh, it's reading blah blah blah, this voltage, and then you go, okay, that equals this dB, this SPL. So again, people though put stuff in pretty packages, and then they go, oh, we've solved your problems. And in a sense, yes, they have, but at what price, or what expense? And that's what you have to ask yourself. So, but I hope that answers some questions about amplifiers. Again, none of this is my information. This is simply stuff that I learned in the electronics school that I went through for Air Force, and then of course I had a ton of questions for those guys, and then you know, they don't cover everything, especially when it comes to, like, especially car amplifiers. Even though a lot of them were like home audio, you know, audio files or whatever they claim to be. Talking about Klipsch La Scala. There's nothing better than the Klipsch La Scala. Yes, there is. There's lots of stuff. But anyways, yeah, this is all in books. And yes, it can be very confusing. And yes, not everybody's cut out for an EE degree, or even like an associate's in electronics or something like that, in electrical engineering. But and even me, I'm not. There's still way too much information that you have to memorize in order to pass the dumb test. And I don't have time for that, and I don't have the need for the pedigree to do that. I just need the information that I need so that I can move on and do what I need to do. So in the case that I've been doing, and that's one of the reasons why I do all these videos, is because I don't have kids and I need an army of people. So I'm recruiting you to do all kinds of stuff that mirrors what I do. I need more guys out there selling stuff. I need more guys out there giving quality information when you're doing an install, or just knowing what the fuck you want to do. I tell you what, you are a prized possession if you know what the fuck you're doing, and then on top of that, you're honest. Oh my God. So, and that's the position I found myself in. And what's funny is that I end up having this huge market advantage over my competitors, just simply because people trust me, and I don't fucking molest them, right? So like that whole FTX thing, you know, and even any kind of token or Bitcoin or something like that, those are actually really good things to have. The problem is people molest the shit out of them. So just like corporations molest people's trust, right? Like that's why your toothpaste went from 8 ounces to 7.5 ounces. And you know, and you're still paying the same price. Again, it's just one of those things that it will catch up to you, and hopefully, you know, all this stuff kind of corrects itself. So with the market and everything like that. But I think that was it. I'm almost home. If you guys have any more questions about amplifiers and things like that, just let me know. And oh, the other one I wanted to cover, I'll cover it when I get home, is the subwoofers and sensitivities, BL, and all that kind of stuff. I want to see if I can find the old Orion manual where it listed the sensitivity when you wired them in parallel as a higher dB rating than in series, which of course is a you could, it depends, it's definitely a mistake. However, sometimes marketing guys will use a mistake like that to their advantage. And they go, well, don't you want it to be louder? All right, then wire it in parallel. This is the dumbest thing. Again, the woofer doesn't know if it's in series or parallel. It just knows, it senses how much wind length, right? That's what BL stands for. The L is the length of wire, and it's translated into the number of windings that sit within the gap. And that's going to give a certain sensitivity or a pushback, electromagnetic field that it's creating. And then the magnet balances back out by pushing with it or against it. So that's it. I'm reaching for straws now. So, but I love you guys. I'll talk to you soon.